In the physical universe, time flows at a constant pace, yet on Earth, life would soon construct thousands of different versions of the present moment. Every living thing requires energy. Cells convert chemical fuel through respiration into ATP, the universal currency that powers movement, growth, and eventually perception itself. As biological complexity increased over hundreds of millions of years, organisms faced a fundamental challenge. Survival demanded precise timing. Why did different creatures need different processing speeds? In predator-prey landscapes, a fraction of a second could mean life or death. Body size, energy demands, and environments shaped these needs. Smaller bodies lose heat faster. Larger ones conserve it. Evolution did not impose one universal clock. Instead, it engineered biological time itself to match each creature's reality. You and a fly are living through completely different versions of this exact second. But why? It begins with energy. Smaller animals have dramatically higher mass-specific metabolic rates. A mouse's heart beats at around 500 to 600 times per minute. An elephant's beats only 25 to 30 times. This is allometric scaling in action. Smaller bodies demand faster energy turnover. Their cells burn fuel at a higher rate per gram, powering quicker lives but shorter ones, often just years versus decades for larger mammals. A hummingbird's heart can exceed 1,000 beats per minute during activity. Its tiny body consumes energy at an extraordinary rate to sustain that frantic existence. Contrast that with a blue whale. Its heart beats only a few times per minute. Its massive body operates on a vastly slower energy economy. Across species, a gram of tissue expends remarkably similar total energy over a lifetime, but the pace at which it is spent defines each creature's tempo. These energy blueprints do more than dictate lifespan. They shape how quickly the nervous system can process the world, and therefore how time itself feels. From simple photoreceptors in ancient oceans, vision evolved to detect light and movement, but not all eyes see the same reality. Over millions of years, nervous systems developed different speeds of neural transmission. Temporal resolution, how quickly the brain updates its picture of the world, varies enormously. Insects like dragonflies and flies achieve flicker fusion frequencies up to 250 or even 300 hertz. They process visual information several times faster than we do. Birds, especially fast flyers and hoverers, often exceed 80 to 140 hertz. Their visual systems evolved for split-second aerial precision. Mammals vary. Many dogs process around 70 to 80 hertz. Reptiles like turtles operate much slower, often below 40 hertz, matching their deliberate pace. Marine animals show similar patterns. Fast predators need rapid visual updates, while larger, slower species process a gentler flow of information. These differences arose through predator-prey evolution and energy trade-offs. Faster processing demands more energy, a cost smaller, high-metabolism animals can afford. Now witness the revelation. Thousands of completely different versions of now unfold simultaneously across Earth. To a fly with a flicker fusion frequency around 250 hertz, your hand moves in graceful slow motion. It has ample time to evade. A dragonfly perceives even finer temporal detail. Its world a high frame rate cinema, where our actions unfold leisurely. A hummingbird experiences the same second with heightened visual clarity, its reactions tuned to its intense metabolic world. A dog or cat sees faster than us, but slower than insects. To a turtle, the hand drifts past like a cloud across the sky. An elephant or whale lives in a calmer temporal world. Their slower processing suits their enormous scale and energy economy. 1 second of physical time contains countless overlapping biological realities, each perfectly adapted for survival. These different biological clocks are not quirks. They are finely honed evolutionary adaptations for survival. For the fly, the bird's beak approaches slowly enough to plot an escape. Its high temporal resolution turns potential death into a manageable dance. Hummingbirds navigate complex aerial environments because their visual system matches their explosive metabolism. Every millisecond counts. Predator and prey evolve in lockstep. A slower perceptual clock suits ambush hunters or armored defenders whose survival relies on patience rather than speed. For elephants and whales, the world unfolds more gradually. Their lower temporal resolution aligns with vast body size and lower mass-specific energy demands. Chemical energy from cellular respiration ultimately becomes conscious perception. Faster metabolism funds faster brains and faster experienced time. What feels instantaneous to us may stretch or compress dramatically for others. Perception is not reality. It is biology's edited version. As humans, we experience the world at around 60 frames per second. This shapes everything we assume about time. A fly dodging our swat sees our hand in slow motion. We struggle because our biological clock is tuned to a different rhythm. Our slower processing supports complex cognition, language, and long-term planning, advantages that came at the cost of raw temporal speed. Evolution did not optimize for one perfect clock. It created diverse solutions matched to each niche, body size, and energy budget. This reveals a profound truth. Physical time is constant, but experience time is relative, constructed by each organism's biology. A fly may live weeks, but experience them with intense temporal density. An elephant lives decades in a more measured flow. Our human perception is just one window onto a world rich with parallel temporal universes, each as valid and real as our own. These biological clocks shape not just survival, but the very nature of consciousness. What feels like a unified now is actually a symphony of overlapping temporal experiences. From cellular respiration to neural processing, evolution converted raw metabolic power into subjective reality. Faster clocks demand more energy, but grant sharper temporal resolution. Predator-prey dynamics drove this diversity. High-speed perception evolved, where split seconds determined life, while slower clocks suited stable, energy-efficient niches. Evolution engineered these different realities not by accident, but through relentless selection for ecological fit. Each clock is a masterpiece of biological timing systems. Our own limitations become clear. We miss much of the ultra-fast world happening around us every moment. This comparative zoology reveals that consciousness itself is filtered through biological clocks shaped over millions of years. Physical time marches uniformly, yet every living creature inhabits its own crafted version of the present. What this reveals is profound. Thousands of completely different versions of now are unfolding simultaneously on our planet. A fly lives a lifetime of intense, rapid moments. A whale experiences decades in serene, flowing calm. Our human perception is merely one frame in this vast temporal mosaic, neither superior nor inferior, simply ours. Evolution did not create one reality. It multiplied them, each perfectly tuned for its bearer's survival and experience. In acknowledging these different clocks, we gain humility and wonder at the ingenuity of life. Time, it turns out, is far more malleable and beautiful than we ever imagined. The impossible biological clock reminds us the world is alive with realities we can scarcely perceive, yet all are wondrously real. What if the second you just experienced passed in an entirely different rhythm for the creatures sharing your world? Evolution didn't just diversify bodies, it diversified realities. Which animal's version of time fascinates you most? Share your thoughts below and explore more of nature's hidden mechanisms in the next chapter of life's extraordinary story.